this demonstration, we're going to be performing two different procedures. We're going to be performing a standard reflash on a small black box immobilizer, and we're also going to be performing a procedure called a cloneout. Let me take a moment and explain what the difference is between those two procedures. Okay, if you're going to do a reflash, if you viewed our previous video on an ECU-based immobilizing system, you know that reflashing is where you introduce a virgin file into the immobilizer, and then after that virginized file has replaced the previous contents of the 8-pin EEPROM, the Automotive Locksmith then introduces new keys to the vehicle, and he will then allow the vehicle to start once those keys are introduced. So that's a reflash operation, and that can be performed on this. This is a small black box immobilizer. This is where Toyota moved the immobilization function out of the ECU and into a separate module. The other procedure is called a cloneout. And a cloneout is where the Automotive Locksmith opens the immobilizer. He attaches to the 8-pin EEPROM. He reads the data from the 8-pin EEPROM, and he saves the file. Once he saves the file, he can then pass that file off to another product. Okay, this is not what the Andromeda system does. The Andromeda system reads the file and allows the locksmith to save it. But he passes the file off to a product called a transponder programmer. And a transponder programmer is a product which will actually physically make the key from the data that was in the file. This is a faster procedure than the reflash, okay, because the information that is specific to the vehicle, the key information, which is in the EEPROM, if you can just take that information and create a key and clone it to a replacement key, then you're done. Okay, there's no learning of keys. Basically, you're making a key directly from the information which is stored in the immobilizer EEPROM. So in this demonstration, we're going to perform first a reflash, and then we're going to perform a cloneout. So you can see how both of those work. If you haven't viewed our previous video, I suggest that you do that. Because I'm not going to go through the setup operation of the programmer, which was done in the previous video. I'm just going to proceed as if you already are aware of that. So just give me a moment and we'll get started. Okay, the first step is to open the immobilizer. This is out of a 2003 through 2006. I'm not sure what year specifically this was removed from. Toyota 4Runner. So you get to it simply by releasing the clips on the side of the package, and set the cover aside, and the immobilizer circuit assembly just slides out. Now the part that we're working with is right here. It's a 93C66. We've already cleaned it so that the clip will fit over the top of the part without any interference, and we shouldn't have any issues with it popping off. So we're going to go ahead and attach the clip to the part. I'll bring the programmer over, and here's the clip is already on the in-circuit adapter. If you look at the part, let me zoom in so you can see it a little bit better. Part is right here, and we're going to attach the clip to the part. Put this on the table. Put the clip over the top of the part. So now the clip is attached to the part, And the next step is we're going to go ahead and just perform the reflash. So what I'm going to do, I'm going to slide the programming unit in here. And something I want to show you that we didn't point out in the first video that we did on reflashing was the socket power LED. Whenever you perform an operation on a module, the socket power LED will turn on and turn off while that operation is being performed. So let me go ahead and start our software. It worked. Okay, so it found the programmer, and now we have the device selection table, which is what you see when the system starts. And this is the 93 C66 part. So we'll enter 93C66, press enter, and there again, as was shown in the previous video, the dip switch settings and the adapter and the switch settings on the adapter. And to get past this, you just hit the space bar and the other key, and it'll clear the information display. All right, so we're going to do a reflash, but before we do the reflash, I'm going to show you a trick. Let's confirm that the clip is indeed connected correctly to the part. Okay, because if it's not, you'll proceed to try to do the reflash and it'll fail because you're not actually hooked up to the chip. One way to accomplish that is to use the verify devices erase command. Well, why does that work? Okay, well, if a device is erased, an erased condition is all ones or all Fs. Okay, well, if the clip isn't hooked to the part, then you're going to have all Fs. And if you have all Fs, then clearly you're not attached. So let's see what this says. If you have something other than Fs, then that's going to appear to be data, and the system will respond and say device not erased. It's just a quick way to determine whether or not you're hooked to the part. So we can say Command 6, and again, with our software, you just press the key, so we're going to use Command 6. It's highlighted on the screen. And device and socket, yes, which that is just another prompt to address whether or not you're hooked to the parts. We're going to say yes, and this says device not erased. Okay, which is good. That means we're hooked up to the part. So we're going to say new device installed, no. So we're back to the main command list. So now we're going to do the reflash. Okay, we're hooked to the part, we've selected our part, and everything should be fine. So I'll tell you what, let's go back and I'll show you something about the programming unit. Let's go back to the overhead cam. I'm going to do Command 6 again, but I'm not going to have the computer display up. I'm going to show you the socket power light on the programming unit. When I'm pressing 6 now, device and socket, watch what happens when I press Y for yes. Okay, so the socket power light lit up briefly while the system accessed the data, accessed the part, and then once it determined that there was data in the device, then the light goes out. Okay, when it's finished with the operation. So that's just how the socket power light works. You don't ever want to do anything whereby you're attaching to a part with the socket power light on, because that means that the socket is powered up, it's hot, and the system is doing something where it has voltages and signals applied to the socket. Okay, now let's move over back to the display, and we're going to go ahead and do the reflash. And like I said, with our software, you just press the keys to execute whatever commands you want to perform. So we're going to press path, we're going to use the arrow keys, and we're going to go over to Locksmith. I'm going to press enter. That takes us back to the main command list, because what we've done when we selected Locksmith, I'll just show you. Let's go back to the path command. If you look down in the lower left-hand corner of the display, you'll see current path is Locksmith. That means it's pointing to Locksmith. New drive path is Locksmith. Well, let's say we wanted to change the drive path to EEPROM. Okay, when I go to EEPROM, it says new drive path : EEPROM. The current path, which is where it's still pointing, is Locksmith. But if I wanted to point it to EEPROM, I can press Enter, or I can press Insert, the INS key, to set the new path. I'm going to press Insert. Okay, now it's changed to EEPROM. Now when I exit, I would be pointing to EEPROM. Okay, if I wanted to go to bin files, I can press Insert and set it to bin files. Okay, if I press Enter, it'll exit the path command. It'll just go back to the main command list after it sets the path where you're working. But I want to work in Locksmith, so I'm going to press Enter now. Locksmith has been selected, and we're back to the main command list. Okay, now we're going to use the System Librarian. This is invoked with the L key, System Librarian. So we're going to press L, and now we're in, if you look here, Library of Locksmith. Okay, and we're going to do a reflash. Not going to go through all of the other issues that are in our previous video. We're just going to go to Toyota, which is right here. And once we're in Toyota, we're going to press Enter. And you'll notice that there's now a cursor down here in the lower pane. This is the information pane. And let me just show you this real quick in the librarian. It's got two modes for this particular demonstration. If I press Escape, I'm going to leave the view mode, and it's going to go back to browse. And browse, you can browse around in the upper pane and see all of the different options. In view mode, it will take the choice that you've made in the upper pane and pull up the information and allow you to move around in the lower pane. Okay, so we're going to press Enter, and again the cursor appears, and the cursor is your selector. So we're going to go to Forerunner 2003 to 2006. So let's go down here, Forerunner 03 to 06. Put the selector on that line, and now as before we're going to press F6, and it brings up notice the status line has changed here. The status line now says mode is program load, file is 35090.cde, and F3 to program. So we're going to reflash it. We're going to press F3 to program. We leave the librarian and invoke command number 1, which is program device and disk file. The disk file has already been loaded. The part has already been selected for you. Notice up at the top it says 93C66, and you're ready to reflash. So let's reflash. We're going to press P. Goes through. Verifying after programming. Program complete. Data verification is correct. Okay, whenever you see something in our software which is green is good. It means it worked and everything is done. If you wanted to reflash another one, you could. This is kind of the standard operation of our system. Program another set. No. So this module has now been reflashed. And because it's been reflashed, you can now reinstall it in the vehicle. But this is a small black box immobilizer, and the procedure for a small black box immobilizer is different than for the ECU-based immobilizers. With the ECU-based immobilizers, as soon as you reflash it, it would learn new keys, and you'd be done. There was no delay. With the small black box immobilizer, you have to wait 30 minutes after you introduce keys, and then you have to resynchronize the updated keys with the key information which is stored in the ECU. Otherwise, the ECU will not recognize it has old key information in it, and the immobilizer has new key information in it, so the vehicle will not start until those two modules are synchronized. So how do you resynchronize or synchronize the reflashed immobilizer box, the small black box, to the ECU? Well, you do that by connecting our resynchronization block, which is part of the locksmith kit, which is this, to the diagnostic port on the vehicle, and you wait 30 minutes. And I wasn't quite sure why Toyota made you wait 30 minutes, but then it occurred to me that if you're a car thief and you just swapped the ECU with an ECU that you already had keys for, all you had to do was get in and start the car and drive it away. If you resynchronize, the resynchronization time is 30 minutes, then you're forced to wait 30 minutes after you have broken in and swapped the immobilizer. That's the only reason I can think of why it would take 30 minutes to do this. But that's what you do. You put this resynchronization block on the diagnostic port. You wait 30 minutes after you've introduced the new keys, and then the new keys information, which you've stored in the small black box immobilizer, will now align with the information that's in the ECU, and you can start the car and get paid. So that is the reflash of a small black box immobilizer. So when you're all finished, slide the circuit assembly back into the box, put the cover back on, reinstall it in the car, and you're finished. Alright, the next procedure we're going to do is called a cloneout. And cloneout is done also by removing the immobilizer circuit assembly from the small black box. But this would eliminate the need for you to perform the 30-minute wait. You don't have to resynchronize the immobilizer to the ECU, because what you're going to do is make a key based on information that is still in the immobilizer. So how do we do that? Okay, well, for this demo, I'm going to use a different attachment mechanism. What I've used before, shown before, has been the blue clip, and you've seen me struggle at times to get the blue clip to attach to the part. You're gonna, assuming that you get it lined up and everything, the blue clip works fine. But we offer another option called the AccuTouch probe, and the AccuTouch probe allows you to connect to the part simply by pushing the probe over the top of the part, and in many cases, you don't even have to clean the part. Alright, this is the AccuTouch probe. The AccuTouch probe is an alternative connection option that we provide. It's not part of the Locksmith package. You have to buy it extra. But it works by simply going over the top of the part. There's a red line or red mark on the end of the probe, which indicates pin 1. So when you push it over the top of the part, you align that red mark in the same direction as pin 1. Also, let me stop here and provide information that I did not provide in the first reflash video, which I indicated that I would, and then I didn't. And that is how to identify pin 1 on an 8-pin double EEPROM. There's two ways. Pin 1 is usually indicated with a dot or a dimple on the package of the part itself. Sometimes it's a white dot, sometimes it's a little indentation in the package of the double EEPROM that indicates pin 1. Sometimes it'll actually even be silkscreened on the circuit assembly. The other way that pin 1 is identified is with a slanted or beveled side. And if you look carefully at the part, if it doesn't have a dimple, look carefully at one side of the part and you see that one side has a slanted side or a beveled side. The other side will go straight down. So you're going to have 4 legs on a side that go straight down and 4 legs on a side which has a beveled edge. If you orient the part so that the beveled edge is vertical, and on the left, pin number 1 is in the upper left-hand corner. So that is the two ways that a device manufacturer that manufactures 8-pin parts indicates pin 1. They always indicate pin 1. They can't put parts on a circuit assembly if they don't know which direction they go, so pin 1 is always marked. Okay, we're going to remove the black plug which was attached to the clip, and we're going to attach the black plug for the AccuTouch probe. It goes on the same headers as the clip, and see, it works the same way. Here it is. So I'm going to slide the programming unit up. I'm going to get the immobilizer assembly, and I'm going to put the probe over the top of the part. Well, let me get it oriented here so it's a little easier to see. And let me zoom in a little bit so it's easier for you to see. Okay, so the probe Here's the red mark. Pin 1 is on this side right here. So I'm going to put the AccuTouch probe over the top of the part. And I'm going to push down and I'm going to hold it. Alright, now that I have it in place, I'm going to go to the computer and we're going to use the buffer editor, which is Command 5, so I'm going to press 5. And there's the buffer editor. The buffer editor has a variety of commands, but one of the commands that it has is called get valid data. Okay, so we're going to press G, which is the editor command. It is all the functions of our software. You just make it work by pressing a key. We're going to press G, finds data, reads data, and it comes up and it says part and buffer match, okay, in green. That means that the data that's in the buffer matches the data that's in the part. Okay, now if you look at the screen, it doesn't look like there's any data there. Well, this is a 250 or a 512 byte part, and the first screen only shows the first 256 bytes. So if we scroll down, you can see right at the end there's some data. And that data is from the reflash that we did. But I'll tell you what, let me pause the demo here, and I'm going to program some data from an unflashed module into this module so you can see this. I think it'll be a little bit easier for you to reference. I was going to do it behind the scenes, but I thought, well, let me just show you how we would do that. That way you can get some better understanding perhaps of how the system works. So what I'm going to do is, we have a file from a Toyota Sequoia. Even though this is not a Sequoia module, we'll just put that file in there. So I'm going to press path, and this file is in the EEPROM folder. So I'm going to go to EEPROM, and then set EEPROM as the working directory. I'm going to say directory of files, and somewhere here we should have a file called sequoia.bin. And if you look down here, it says F3 to program, F4 to load, so I'm going to press F3, and I'm going to say program, and we now have programmed the Sequoia file into the Forerunner EEPROM. Okay, but I did that so you'd be able to see the file. So we'll go back to the buffer editor, which is Command 5, and there is new data. Okay, we're going to clear this out. We clear with a C key, clear. Okay, now it's cleared. So again, referencing back, I'm putting the AccuTouch Turbo on it. This is at this point, assume this is new, and we're now going to use the get valid data command to do the cloneout. So we're going to press G. Reads the data, compares the data. There is the data that you would use to send to your transponder programmer to make the key directly. All right, well, how do I save the data? All right, well, you save the data, press the space bar, and let me just show you something here. You can get out of the editor pressing escape. All of our commands exit by pressing escape. All of the commands, not all, some of the commands that are in the main command list are also in the buffer editor. Okay, so in this case we're going to use Command A, which is up here, which is save buffer to disk file. All right, and Command A will allow you to literally just save it. It'll save what you need to save in the buffer to a file, and then you access that file with your transponder programmer software. But I'll show you something else. Let's press P and use the path command. Well, where would we want to save this? Probably not in Locksmith, because there's a whole bunch of Locksmith specific files there. Probably not in EEPROM, because that's where all of the EEPROM plus files are that are used by our system. So what if we made a new directory or a new folder? And let's call that folder or directory Cloneout. Okay. So in order to make a new folder, we have a feature in the path command which will let you do that. And in order to do that, we just want to put it in on drive C. So I'm going to press F10. the F10 key, and if you'll notice down here, when I pressed F10, the current path became C. So we're just pointing at drive C. Now, you can do an Alt-A, A for add, and here is the function, add new directory to current path. Current path is C. So let's give the name of Cloneout, C-L-O-N-E-O-U-T. Now watch when I press enter. Add new directory now, yes. New directory created, and now we have right here Cloneout. Okay, but our current path is still C:, still drive C. So we want to change that path to Cloneout. So all we got to do is highlight it, and press enter, and now let's just go back to the buffer editor so you can see how this works. Go back to the buffer editor, and we're going to press Command A, which A is in the buffer editor, and A is also in the main command list. And if you notice, our current path is now Cloneout. That means that this file is going to go to the Cloneout directory or folder, and that's where you'll find it with your transponder programmer. So let's get a file name. We're going to call it Forerunner. Forerunner.bin. Now, why do we give it a bin extension? Okay, well, bin stands for binary, and a lot of transponder programmers will they won't process the file unless it has a .bin extension. Many times they won't even display the file if it doesn't have a .bin extension. With our product, you can name it whatever you want, but a lot of those third-party products will not work with a file unless it has the .bin extension. So there's the name I've given it. I'm going to press enter, and the next thing that you see, it says save defined buffer range. Okay, we automatically know, based on the size of the chip, how much buffer that needs to be saved. So it says save defined range 0 to 1 FF. That's the 512 bytes that compose the information that came from the part. And now to confirm that you want to go ahead and save it, you press Y for yes. It'll say file save complete, and you're done. Well, how do you know it's there? Well, let's go back and look. If you look here, we have Command D, which is directory of files, and if I press D, there you see forerunner.bin, and the file is in the Cloneout directory. So what you would do at this point is you're done as far as our product goes. You would now use your transponder programmer. You'd navigate with Windows to Cloneout, and let me just show you this too while I'm doing this demo. So using Windows, we're going to navigate to drive C, local drive C, and you'll notice here is a folder called Cloneout. So let's open the folder, and there's your file, forerunner.bin. Now, you could have created the Cloneout with Windows, and we would have seen it. So it doesn't matter where you do it. I just wanted to show you the capability that you have if you wanted to create your own folder, and you can do this for anything you're working on. There's no need to save your files in EEPROM, that's the default directory that we point to when the system starts. But you can make many directories as you want. So I just wanted to show you that feature, and at this point we're done. So we've now done a reflash on this module, and we've done a cloneout where we've read the data and put it into a file in a folder name, directory name that we created, so you know how to do that. And I guess the other thing that I'd like to say before we conclude is that if you were running this outside of Windows, meaning on a machine that had Linux, on a machine that had no hard drive running from a USB drive, it would still work just exactly like you've seen. The commands are the same. Everything works the same way. It's one of the unique features of the product that we sell is You don't have to have it installed under Windows unless you want to. You can carry it from place to place and use it on as many machines as you want. So that pretty much wraps it up. We appreciate you watching. If you have any questions about use of the system, or would like to talk to us about how the product works or other things that we sell, the information is on our website, which is airlabs.com.